Welcome to the online platform of KTCD College of Arts and Science. I am RESHMISREE, HoD Department of Mathematics. In this video, we describe about the axiom of completeness. Axiom of completeness. What is axiom of completeness means? The statement is as follows. Every non-empty set of real numbers that is bounded above has a least upper bound or supremum. Every non-empty set of real numbers that is bounded above has a least upper bound supremum. Now, what exactly does this mean? We don't know about what is a bounded above set, and we did not know about least upper bound or supremum. What does this exactly means? Let us first take the relevant definitions and then look at some examples. Above, bounded above set and below sets. Supremum and another one is infimum. Now we are going to section least. What is least upper bound and what is greatest lower bound? What is least upper bound and what is greatest lower bound? So let A subset or equal to R, which is bounded above if there exists a number B belongs to R such that A less than or equal to B for all A belongs to A. The number B is called the upper bound for A. So, given a subset of real number A, that set is called bounded above if there exists an element B in R such that A less than or equal to B for all A belongs to A. Then the number B is called upper bound for A. Now look at the example. Let A equal to 1, 2, 3, 4, 5. Here, which is the maximum element in A? Which is the maximum element in A? Yes, it is 5, isn't it? So, this 5 is bounded above, or 5 is called upper bound if for all A belongs to R, this 5 will be maximum element. Okay, we can look that. We know that 1 less than or equal to 5, 2 less than or equal to 5, similarly 3 less than or equal to 5, also 4 less than or equal to 5, and finally 5 equal to 5. So by definition of upper bound states that the B is called the upper bound. B is called an upper bound for A. For all A belongs to A, we have A less than or equal to B. That means for all A belongs to, here the set of elements in A are 1, 2, 3, 4 and 5. For all A in A, that is for 1 less than or equal to B. B means this 5 now. Second one, 2 less than or equal to 5, 3 less than or equal to 5, 4 less than or equal to 5, 5 equal to 5. So the number 5 is called upper bound for this set A. Okay, that is A subset or R is bounded above if there exists an element B in R such that for all A in A, that is 1, 2, 3, 4, 5. For all A in A, we have A less than or equal to B. We have A less than or equal to B. Then the number B is called the upper bound for A. Similarly, we can prove the lower bound of A. Here, which number is the minimum element of the set? 1. The definition states that a set A subset or equal to R is said to be bounded below. There exists a number L belongs to R. There exists a number L belongs to R such that L will be less than or equal to A for all A belongs to A. Then the number L is called the lower bound for A. Here, which is the minimum element? 1. So 1 is equal to 1. We know that. Then 1 less than 2. Similarly, 1 less than 3. 1 less than 4. Then 1 less than 5. That is, for every A belongs to A, the number belongs to A are 1, 2, 3, 4 and 5. For every A belongs to A, we have 1 will be less than the element in A. Okay, then the number 1 is called lower bound for A. Then 1 is called lower bound for A. The set is called bounded below set. The set is called bounded below set. If a set has an upper bound, then that set is called bounded above set. If a set has lower bound, then that set is called bounded below set. Okay. Next we are going to another definition, another important definition, that is supremum or least upper bounds. Here also consider the set A is equal to 1, 2, 3. Here, which is the bounded above, this set is a bounded above set. Which is the upper bound? Yes, here 3 is the upper bound, since 1 less than 3, 3 is the upper bound, since what was the reason? 1 less than 3, 2 less than 3, also 3 less than or equal to 3. Okay, so 3 is the upper bound of the set A, which is also a subset or equal to R. Then, if B is an upper bound, B is any upper bound for A, then S less than or equal to B. First condition for the supremum is S is an upper bound for A. Here 3 is an upper bound of A. If B is any upper bound for A, then S less than or equal to B, then that is called the supremum of A and is denoted by S is equal to sup A or S is equal to least upper bound, LUB, least upper bound A. So, what does this actually mean? Consider the real line. Here 1, 2, 3. This is A and that is subset or equal to subset of real numbers. Then we can say that this 3 is the least upper bound. If, first of all, 3 is an upper bound for A. Obviously 3 is an upper bound for A. Now, if B is any upper bound for A, then S less than or equal to B. There are so many upper bounds. There are so many upper bounds in this set, excluding 3. They are, some of the upper bounds are 4, 5, 6, etc. These are some of the upper bounds. So, 4 is, if we have an upper bound for A, that is B. Here 4 is an upper bound. then that 4 must be less than the least, then less than the upper bound of A. Then that upper bound is called supremum or least upper bound. Here also 3, if we take another element 5, then 3 will less than 5. So 5 is an upper bound, 4 is an upper bound, 4.5 is an upper bound, 6.5 is an upper bound. There are so many upper bounds. In that case, 3 is the least upper bound for the set A. So a real number S, here a real number 3 is called the least upper bound or supremum for a set A if it meets the following two criteria. First criteria is that S is an upper bound for A. Here 3 is an upper bound for A. Okay. Now, if B is any upper bound for A, that is 4, 5 or 6. If we take B is any upper bound for A, then that upper bound will less than the upper bound of A. That is 3 is less than 4, 3 is less than 5, 3 is less than 6, 3 is less than 10. Then that 3 is called the least upper bound, and we write it as a SUP, supremum of A, equal to 3. Okay. So it has an upper bound if it has supremum. That is called the axiom of completeness. Axiom of completeness states that every non-empty set of real numbers that is bounded above, every non-empty set of real numbers that is bounded above has a least upper bound, and that least upper bound is otherwise called as supremum of the set. So every non-empty set of real numbers that is bounded above has a least upper bound or supremum. And this property is also called as completeness property. Completeness property. So axiom of completeness is that every non-empty set of real numbers that is bounded above has a least upper bound or a supremum. Okay, this axiom of completeness is otherwise called as completeness property. Now, the next definition is about the infimum. What is infimum? We are already proved that there is a supremum exists. So, similarly we can prove for there exists a lower bound, and lower bound has a greatest number, and that number is called the infimum of the set. Now, consider the set A equal to set 1, 2, 3. Here 1 is the lower bound of the set, but there are other lower bounds in this set. Here 1, 2, 3, 0, -1, -2, -3, etc. is also a subset of real number. Okay, then this number L, that is this number 1, is called the greatest lower bound or infimum. If L is a lower bound for A, here L is the lower bound for A, since 1 is the minimum element in A. And if T is any lower bound for A, there are so many lower bounds in here. Here -1 is a lower bound, 0 is a lower bound, 2 is a lower bound, -3 is another lower bound, etc. So, if T is any lower bound for A, then T will be less than or equal to L. Then T will be less than or equal to L. That means, if we take T as 0, then 0 will be less than 1, the lower bound. 1 is a lower bound. If we take another element minus 1, then that will also less than 1. So this 1 is called the greatest lower bound, and we write the greatest lower bound as GLA, or L is equal to infimum of A, or L is equal to infimum of A. In this set, here the set is bounded above. Bounded above means it has an element, maximum element, and it will be 3, and in this set will be 3, and in this set has a minimum element, it is 1. So a set is said to be bounded if it has bounded above as well as bounded below. Okay, a set S is said to be bounded if it is bounded above as well as bounded below. This figure gives a clear picture about the supremum and infimum. So look at the figure. This is a real line, and A subset equal to R. Here there are so many lower bounds. The maximum of the lower bound is the minimum element in A, that is called infimum of A. There are so many upper bounds in this set. The minimum element of the upper bound, and it will be the maximum of the element A, that is called the supremum of A. Okay. Now look at the examples. Some of the examples are given here. The first set. Here in the set natural number, n is equal to 1, 2, 3, etc. Here the minimum element in the natural element is 1, isn't it? What will be the maximum element? Yes, we cannot find a maximum element in the set of natural numbers, isn't it? So the minimum element 1 is the lower bound, and this set is called a bounded below set. 1 is the lower bound of the set, and that 1 is the infimum of n. Infimum of n is 1, because there are many other elements in real numbers which will be less than this 1, but here is no upper bound element, so supremum of n does not exist. This is one of the important property of natural number. Infimum will be 1 and the supremum does not exist. This set is not bounded above. This set is bounded below set. N is a bounded below set. Supremum does not exist. And next question is, S is equal to 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6. This set has a lower bound. Which is the lower bound? It is 1 by 6. Which is the upper bound? It is 1. Similarly, we can say that the supremum of S is equal to 1 and infimum of S is equal to 1 by 6. This set has both the bounded below and bounded above elements. So the set is bounded set. Next example is also about a bounded set. Here the supremum is 7 and infimum is 3. This is a bounded set. And the next example, B equal to minus of n plus 1 by n, where n belongs to n. Substitute n equal to 1, n equal to 2, n equal to 3, etc. We get the elements minus 2, minus 3 by 2, minus 4 by 3, minus 5 by 4, etc. This set has a minimum element, that is minus 2, and a maximum element, it is minus 1. So minus 1 does not belong this set B, since it tends to go into minus 1. But the problem is that minus 1 does not belong to B, even if we write the supremum of B is equal to minus 1. Next example is an open interval. C is equal to open interval 2, 3. This is also a bounded set. Here the minimum element is 2 and the maximum element is 3. So there exists a infimum of C, that is 2, and supremum of C equal to 3. But these two elements does not belong to the set. Next example. Each of the sets is such. What is a set? Z is a set of integers. Q, set of rationals. R, set of real numbers, which is bounded neither below nor above. That is, we cannot find a minimum element or maximum element from Z, Q and R. So that set is not bounded above and not bounded below set. Next example is S is equal to closed interval minus 1, 1 union open interval 2, 3. It is also a bounded set. Supremum of S is equal to maximum element is 3 and the minimum element is minus 1. So supremum equal to supremum of S equal to 3 and infimum of S is equal to minus 1. This is an important property. We are stating that the axiom of completeness is every non-empty set of real numbers that is bounded above has a least upper bound or supremum. Thank you.